Yeah, very good morning to all. So let me share the file. So today we are going to discuss the Gause theorem. So what is the importance of Gause theorem? So why we need to learn this? That's important. I have to ask. Why we need to learn this Gause theorem? Does anyone knows? Please share it. So why we need to learn this Gause theorem? So please let me know. Does anyone knows? So what is the Gauss theorem? I mean, why we need to learn? We already learned this, the basics in the intermediate. So why we got this Gauss theorem? What is the Gauss surface? We also discussed the Gaussian surface, where integral E dot ds equal to, right, q by epsilon naught. So we learned this one, right? Did you learn it? And we also learn this, b dot ds equal to 0. So what we learn this one, actually the flux of the electrical flux must be equals to q by epsilon, charge over epsilon naught. The magnetic flux should be equal to 0. So whenever you have the surface area like this, okay, you have the charge enclosed here, you have a charge here. Whenever you have a charge, you draw the symmetrical surface around it. The charge enclosed by this surface must be equal to flux around it. What is the flux? The magnetic field lines passing through unit area. So this gives the flux of a field. If you're talking electrical field, you're gonna get this one. If you're talking magnetic field, you're gonna get this. So why we are getting here 0? Why we are not getting in case of electricity? Anybody want to share your idea? Upender, anyone who want to share it? Why magnetic flux equal to 0? Why not electrical flux equal to not equal to 0? Does anyone please share your unmute and talk to me? Please, Upender, do you want to discuss? Do you want to talk? Do you have any idea? If you don't know, just
No,
please.
sir. No, sir.
So in case of magnetic, or magnetic, suppose if you take north and south, if I cut this piece also, I can get the north and south again, right? Even if I cut again, I'm gonna get north and south again, right? Even if I cut dot also, north and south is there, right? So hence monopole does not exist. Monopole does not exist. This point is very important. In interviews, in whatever in the future, in case of electricity, you can exist positive charge or negative charge. Single charge also can exist. Single charge can exist in case of electricity. In case of magnetism, it is impossible to exist monopole. North pole gaani south pole gaani exist avutunda?
No.
ఒక
No, sir.
ఒక సింగిల్ నార్త్ ని మనం చూడగలుగుతాం magnetism లో? No, right? We can't, right? But we can see single electron, right? So monopoles exist in the case of electricity. Is it clear? But
Yes, sir.
monopole does not exist in case of magnetism. Is it clear now?
Yes, sir.
So electricity law, it is possible to have the single electron, whereas in magnetism, it is not possible to have the single north pole or single south pole. It always in a pair. The dipole, we call it as a dipole. Right? We have an electric dipole, we have a magnetic dipole, right? So magnetic dipole cannot break it as a single pole, but electric dipole can exist as a single pole. So is it clear?
Yes, sir.
You note down the
Yes,
bullet
sir.
points.
Yes, sir.
Right. I don't want to ask you, please note down, please note down. That is you are a degree student now. It's your responsibility to write bullet points, to write something like, for future purpose. Like, everything I cannot ask you to write down, write down. But theorem, definitely I'll tell you this theorem is long answer. You have to copy. But other things, important points, you always keep in the mind, and you always keep the, some track the notes, rough notes or whatever notes, bullet points. So the purpose of this theorem also came from here, the flux. We took the symmetric surface equal to Q by epsilon naught. Q, what is the charge definition? What is the charge? Rho dV, right? What is the charge? Charge must be equal to total charge equal to, actually this is the formula beta. The formula is actually dq is equal to rho dv beta. Sorry, dv. Okay. So when I do the integral on both sides, I got actually q, charge. So actual formula charge should be equal to integral of rho dv. Integral of, oh sorry color, I have to change it, right? Integral of rho dv by epsilon naught, 1 by epsilon naught. Is it clear?
Yes, sir.
So this makes sense this side and this makes sense this side. Okay. So what I'm writing is here divergence V here. It's like a rho dv. Okay. So this came from here. So now I am going to clear it. I told this, I spent time to explain the importance of this. So this came into picture. Gause theorem case in, it came into the picture to talk about the flux, magnetic flux or electrical flux. In mathematics, we don't talk much, but you have to learn in maths also. You're going to learn this again in the maths, third year BSc. So if you are expert now, this also helps in the third year BSc. Okay. So this always explains the flux of charge or flux of field, or flux of magnetic field. So what is the statement? The surface normal integral of vector taken over the surface. Note down. The surface, you have to take one surface. Here you have a charge, let's say, or vector A. The surface normal integral vector taken over the closed surface, is equal to volume integral of divergence vector, over the volume enclosed by the surface. The definition, is it clear? Let me repeat again. Simply beta, surface integral of vector must be equal to volume integral of the divergence of vector. That is the statement of Gause theorem. Does anyone, can you repeat again? Can you repeat in your brain? Surface integral of any vector must be equal to the volume integral of divergence vector is called Gause theorem. Is it okay?
Okay, sir.
Can you repeat in the brain?
Yes, sir.
Surface integral of any vector must be equal to the volume integral of
Divergence of a vector.
divergence of that particular vector. If you are considering a vector, you should take the surface integral. Surface means you are taking that Surface indicate it should be dx dy. When you are doing surface integral, it could be dx dy, dy dz, dz dx. Any two only. Surface means. And divergence of a vector, the same vector. Volume integral. Volume means dx, dy, dz. Is it clear?
Yes, sir.
Yes, sir.
So this is what you should remember better. Surface means any two integral. 2 times you have to do. Volume means you have to do the 3 times. So I am going to clear it. So now let us go for this is the theorem. Theorem of statement is over now. Surface integral of any vector must be equal to volume integral of divergence. A vector is called Gause theorem. This is over. Statement is over. 1 mark is over. Okay. Now moving.
Okay, sir.
Now moving into the derivation. We have to prove this. Left hand side must be equal to the right hand side. Right? Is it? So you should take left hand side must be equal to the right hand side. Sir, I didn't get it. So why we are writing here again, sir? This is del A is equal to divergence means what? Divergence means this is the symbol we are using. dv is clear. Why I am writing A? So this I am writing as a ds is a surface vector. I can write it as a unit vector into ds. So ds vector I am writing as what I am writing is unit vector n and ds. Still it makes sense. So because we have to do the integral with respect to ds should be maybe dx dy. If it is a xy surface, if it is a yz surface, dy dz. If it is xz surface, dx dz. So this statement should remember forever for you. Okay. So then the statement is over. So now I have to prove. How I should prove it? Proof. So proof again very easy beta, but we have to do it very carefully. So now consider a small volume element. So it should be dx, dy, dz. As I mentioned, dx, dy means volume integral. 3 times you have to do dx, dy, dz. Volume is length into length into length, length into breadth into height. 3D basically when you are taking the small, this has a length, this has a breadth, this has also height. So dx, dy and dz. Okay. So you have to multiply in order to get dv. Volume integral must be equal to product of the small element. Enclose the surface. Surface should be like this. One piece you are considering now. Okay. Then the definition is what? Divergence A equal to, here you are taking a vector A. Okay. And divergence must be equal to V. According to definition, what we know? Dou by dou x of I, dou by dou y of j, dou by dou z of k. Then A vector is equal to what? A can be resolved into 3 components. So AXI plus AYJ plus AZK. So A should have a 3 vectors, right? X, Y, Z combination. So AX, AY, AZ. So along Y-axis, X-axis I, along J-axis J, along Z-axis K. So this is a vector I am writing. Divergence A means del vector. This is the del. Del I wrote it here. A I wrote it here. So when you do the dot product, so you have to multiply this. Dou by dou x of I dot I how much? I dot I is equal to
1, sir.
so 1. I dot I 1. So I can write it only dou ax by dou y. J dot j is also 1. So no vector. We're going to get scalar quantity. We're going to get scalar quantity. j dot j1 dou a y by dou y, dou a z by dou z. This is the divergence A. I got it. So here ax, ay, az, what are these magnitudes? Ax, ay, az are the magnitudes of that particular x component. So are components, you can tell, right, a components, not magnitude, components of x comma y comma z vectors. Okay, now yeah, you wrote it here, components of vector A along x-axis, y-axis, z-axis, multiplying on both sides by dx, dy, dz, we get what? You have to multiply in both sides. What do you have to do? Divergence A, dx, dy, dz. I am also doing dx, dy. Both sides I am doing the same quantity. You just need to write it this. Did you copy this slide? Over?
Wait, sir.
అయిపోయిందా?
Copied, sir.
No, sir. Wait, sir.
చేసుకో, you have to complete it. Karthik Reddy add చేయండి. You have to add Karthik Reddy, just waiting for to add. Someone can add it. So can I erase it? I mean, can I clear it?
Yes, sir.
Right. I'm going to move to the next slide. Okay. I'm just multiplying. What it is, simply divergence I calculated and I multiplied both sides by dx, dy, dz. Right?
Yes, sir.
Long answer question. Very careful, guys. Oof. Come on. What's going on this? Okay. Right. So after that, what I got it, integrating both sides. Both sides you have to apply volume integral. Both sides you have to apply this. Why? Because you have the dx, dy, dz, right? So you have to apply 3 times integral on both sides. So left side I applied it, right side also I am applying it. Okay, is it clear? So applying integral on both sides. So when I apply both sides, what I'm gonna write, dx, dy, dz, I'm writing as a dv. Can I write it? I can write it dv, right? Volume integral component, multiply of x component, y component, z component. So LBH, it's volume, right?
Yes, sir.
Take small piece, so going to be dv. So on the left side, I wrote it as this product of dx, dy, dz as dv. Okay. So on the right, so when I keep dv, I have to keep here volume symbol. I don't need to write 3 times symbol this one. One time I can write it as and then put a v symbol. So I don't need to write 3 times integral because dv indicates 3 times we have to do it, and v also it represents volume over the surface. Okay. So now on the right side, if you are coming to the right side, what we have, the first component into this, second component into this, third component into this, you have to multiply it. Okay. So when I do that, someone is a new, okay, all okay, right? So multiply this every component with dx, dy, dz. So I split it like this, 3, I got it. Right? Then what I got it here, what I'm trying to write it here, I'm going to write it here. I'm separating actually because here this is x component beta. I am doing this is with respect to only dx, right? So I'm splitting 3 integral into 1 integral for x two other integral for dy and dz. Okay, so dAx by dx into dx, that I got it here, and the remaining two I'm writing here. ఓకే, ఇక్కడ రాస్తున్నాను. ఇక్కడ కూడా ఏం చేస్తున్నానంటే ఇక్కడ y ఉంది కాబట్టి, so here y is there, so dou ay by dou y, so I should write it as a dy here, right? Then remaining what are left here, dx component and dz, so I'm writing here. Similarly, when you are writing for z, one integral goes for a dou az by dou z into dz, then remaining component dx dy. I'm just writing, splitting 3 integral into 1 2. Okay, is it clear, this step?
Clear, sir.
Yes, sir.
Okay, then here since ax, ay, az are the functions of only one variable, ax is a function of x, ay is a function of y, az is a function of z. So when we can change the partial derivative into total derivative, because only function of x, so we can go for the dou into d. So what is the dou difference and d difference? When you get the exact value, we can use this one, exact derivatives. If you don't have the exact,
partial derivations,
you have to go for the partial. Partial means you don't know exactly, so it could be x, y, z or whatever it is, but when you know it is only x, you can go for the exact. So from here to here I am going for exact, dou ax by dou x with a function of x only, so I can write dou ax by dx, dax by dx. Same I am writing, I did not change anything here, only shifting into the dou to d, right? Only I'm just shifting into dou into the d's completely, because you have separated the functions, right? So then what happened, and the left side quantity as I am writing here, same as this left side one, and the right side one, when you are doing nana dx cancel, you can exact, right? They are exact, so exact derivatives, dx you can cancel it, right? So here also dy cancel it, dz cancel it. So what is going to be this one, tell me nana? Integral of dax, we're gonna get ax, right? Right? Integral of dou day, we're gonna get ay. Integral of daz, we're gonna get az only. Why? D cancel with integral. Here d means what? D and integral both are inverse, right? So inverse cancel with, if you have a dx, what is the value here, tell me? X, right? Student, why dx is equal, integral dx is equal to 1, tell me? Does anyone know this? Why integral dx is equal to 1? No, it's x, right? It's x, right? Student,
Yes, sir. Integral d cancel, sir. X.
Yes, sir.
can anyone prove that one? How do you prove it?
Sir, derivative d cancel, sir.
అది డెరివేటివ్ ఇంటిగ్రల్ క్యాన్సిల్
sir,
అవుతుంది, ఎలా
integration
వస్తుంది?
cancel with this.
సో ఇక్కడ 1 power 0 ఉంటుంది బేటా, 1 power
0.
1 power 0 అంటే 1 కదా. సో there is a formula for integral x power n.
Answer integral 1 dx.
N x power n minus 1, sir.
Yes, x power n plus 1 by n plus 1. So n is equal to 0 here, right? So 0 plus 1 by 0 plus 1. So you're going to get x only, right? Is it clear why we are getting here x? Please, students,
Okay, sir.
we are applying
Yes,
the
sir.
integral formula. Yes. Yes, please.
Yes, sir.
Yes, sir.
dx is equal to x, integral dx equal to x. Why? Because 1 power 0 we can write it as 1 power 0 plus 1 by 1 power, sorry, 0 plus 1. This is going to be 1 power 1 by 1. This is going to be 1 by 1 only. Why? Because x power n formula we have used here. This is going to be x power n plus 1 by n plus 1. So most of you know that integral because you guys are MPC only. So I guess you understood this. So now I wrote it as I got this one is this x. I got this one is equal to ay. I got this one is equal to z. Remaining I wrote as it is. Is it clear up to this step?
Yes, sir.
Can I move to next slide?
Yes, sir.
Yes, sir.
So no doubt at all. Right? We are almost there. Almost derivation is over.
Okay, sir.
Right. So now the question is diverge. So left side one as it is there. Right side one, what I am writing is, can I let me go for back again. What happened? So here what I am writing is here. Let me explain here only. This is equal to ds. This is also equal to ds. This is also equal to ds, right? dsy, ds, sorry, dsz, dsx. No, don't. I cannot write those. Yeah, simply ds. So ds, right? It could be anything, but this is surface, right? So ds could be, it could be dx, dy, dy, dz, or dz, or dz, dx. So anything is, you can write it as a ds, right?
Yes, sir.
So I'm going for the next slide to show directly this step. So here I'm writing, you can see here. So I'm going to teach only this today because long answer I don't want you to lose it. So left side this one, right side I'm writing ax. This is here x. This is actually xy surface. Since you have only ax, you can write dsx. Here ay is there, dsy, az is there, dsz. Okay. So then what happened? You bring this one into inner, like you can bring this into the inside of the integral. So you can bring this one to here, you can bring this one to here. I got this. So then after that, you can write it as a integral common. Two integrals are all same. So I'm taking integral common. So ax dx x, ay ds y, az ds z. Then again, how can I write this one? Tell me. I'm writing like, I have a vector like, ax I plus ay j plus az k. Then I have a vector like, ds vector too. sxy, syj, szk. So when I do the dot product of this, what I'm going to get? Tell me. Dot product of this ax sx, ay
SY,
y,
AZ,
az sz. Is it clear?
sir.
So I'm writing that directly here. This entire component I'm writing as a dot dx. Okay. Hence the theorem is proved. So this is the theorem. The theorem enable us to transform surface integral into volume integral. So what is the very good application? You can see if you have a surface integral, okay, you can simply is equal to the divergence of the that vector dv. Suppose if they ask you to do this one, you can do this one. If they ask you to do this one, you can also do this one. Both answers are correct. Wonderful application. I mean, converting the surface integral into volume integral. This is really wonderful theorem. Gause theorem enables us to transform a surface integral into volume integral or volume integral into surface integral. Really wonderful theorem. And this helps a lot in physics, in chemistry, and mathematics, or any engineering branches. Okay? So is it clear for all of you?
Yes, sir.
Yes, sir.
I hope it's clear, but it's a very important theorem. Can't answer question. 12 marks. 12 marks question. So we have proved that. This is a proof, final proof. So I guess you don't have any doubt. Please let me know. Ever can doubts unnayi beta?
No, sir.
Inka evarana, please.
No, sir.
Let me go back and tell me where you have a question. So there is a actual theorem, we took it. So this is the question. So what we have done is, the surface integral of any vector must be equal to volume integral of divergence that vector. We have proved that both are equal. Okay, then we took the right side one. We took the right side one and we wrote it as a diverge A equal to divergence A. Then what we have done is equal to can anyone post the attendance? Can I post it, or do you want to post it? Can you copy and post again from the chat box? Is it okay?
Okay.
Are you able to do it, or can I help you? Students, any question?
Yes, sir.
You can post it, Nana. Upender, you can post it. Yeah.
Okay.
So this step, I think this slide is fine for you all. I did not do anything better. Simply what I did is, diverge. I know I already know this diverge. This is a diverge, and I already know the A. I just multiply the dot product. I got the scalar component. Okay. So then I applied both side dx dy dz. Then I also applied the volume integral both side. So first I took this one divergence, then applied the both side dx dy dz. Then I also apply the integral on both side. Then what I did is here simply I separated the triple integral into single integral and double integral. Okay. Then what I did is I made it like for dx will cancel. You get only ax and ay az, and the other one is actually surface ds dsx dsy dsz, and then finally I wrote it as I brought this into ax dxy ay dxy az dsz. Then again I took integral common, then I got it as a dot ds. So wonderful theorem. I would really if you would have understood this, really it helps a lot for your future. So this also can be written as the triple integral of divergence dv divergence divergence A.
DV.
Excuse me, sir.
Yes, no, wait. Let me explain this. Double A dx. It could be ds beta. It could be ds. I can write it, but dv it should be dx, dy, dz. Again, ds should be equal to, as I told you, depend upon the surface. It could be anything, ds, dxy, dy, dz, or dz, dx. Okay? Yeah. Tell me now.
9:20 is there max class, sir. So we have to complete fast, sir.
Over. Mine is over. I have a class actually. Now I think joined my finalist will already join, I guess. My final students already joined. I have to stop now. So thank you for asking. Like, thank you for reminder actually. Okay.
Thank
So thank you, Nana. I think hope you understand all, right?
you, sir.
Yes, sir.
Tomorrow you have to, your homework is to write again one more time this. Okay.
Yes, sir.
Yes, sir.
I'll ask one of you to do on the board.
Okay, sir.
Okay, sir.
మీరే చేయాలి, నేను చూస్తుంటాను, నువ్వే బోర్డు మీద రాలి. One of you have to come forward and write on the board.
Okay, sir.
Okay.
Okay, sir.
Right. And all the best. Have a wonderful day. Thank you. Attendance. Did you guys finish the attendance?
Yes, sir.
Okay.
Yes, sir.
Finally, students are joining now.
Thank you, sir. Bye, sir.
Thank you. Finally, student, can you join again? I'll stop and because I have to record it, right?
Okay, sir.
Finally, student, please join again. I'm closing now. I'll stop this and again I'll give the access for you.